Hello, thanks for coming. So my name is Vincent. I'm with The Boundary. I'm the real-time technical art director at The Boundary, and my talk is about building realistic large-scale worlds for multi-purpose outputs. Now, it's kind of a mouthful, but hopefully this will make sense at the end of the talk. So, first I want to introduce who The Boundary is. We are a player in the AECO industry. After this, I'll basically like to use a case study, Laik Island, to present how we build worlds at The Boundary, and then how we use that world to create a lot of different output out of it. But one that I'm particularly passionate about is creating pre-rendered content using path tracing. So this is what I'm going to mostly be focusing on at the end of the talk. Cool. So we're a studio with 5 studios all around the world. It started in London, and then Auckland, where I'm from, joined The Boundary, and now we're expanding to New York, Porto, and Dubai. Yeah, we've got a decade of experience, but really the people who work in the company itself, they have about 20 years of experience all added together. So this is just a little sizzle reel. We're an architectural visualization company, so we're doing images, we're doing film, and then in the last 10 years, we've been doing a lot of interactive and real time. So we've got virtual production, we've got large-scale digital twin, we've got virtual tour for interiors, we've got experiences, we got products. We get a bit of everything. But today, I mostly want to focus on everything real time. Cool. So in terms of real-time product, we have an interior pipeline, we have an exterior pipeline, we build experiences. These could be sort of VR experiences, or I guess display suite experiences, or I guess product experiences. And then we're also doing virtual production. So my talk will be focusing on the exterior stream, because this is my pipeline. It is quite different from the interior stream. So the interior at this point is still using baked lighting. Everything that we do with the exterior pipeline is using dynamic lighting and all the latest UE5 technologies. And the project that I want to be using is Laik Island. It's a project by Red Sea Global, and it's a residential-led development at the Red Sea. So what is Laik? It's a 6-kilometer long island. It's about 400 hectares. It's been designed and conceptualized as a forever garden. So it's going to make it very challenging for us to be able to visualize it correctly, and also to constantly stream in and out all of this geometry. But hopefully, as you can see in the video, we've done a good job of it. There's more than 550 villas, and it all needs to be high quality, highly detailed. There's a crazy 800-meter diameter apartment and hotel complex known as the Ring at the center of it. 800-meter in diameter, I think we calculated, but it's basically kilometers of architecture, unique architecture that we have to integrate within this project. There's many amenities. There's like an 18-hole golf course. There's bars everywhere. And I guess, we have to create everything. And we have to be able to see it from a regional view to a district view to like a medium distance view, and all the way down to the ground level. And everything needs to look good, and everything needs to load super fast. Games usually don't need to move around this fast. Usually games can use loading zone or something like this to achieve this kind of results. So that's been the most challenging and most fun part of this for me, is really trying to push the boundary of how much can I actually show at every level without really getting too many hitches. We're really pushing the World Partition system with this project, and it's going to be part of the things I'm going to be talking about. Our client's goal in this particular case was to create an interactive sales application. It's something that we do at The Boundary. We have a sales app. Most of our Unreal experiences are wrapped within this sales app. It's really our way of deploying our projects to our clients. We're not just shipping just random executable. Everything comes with a launcher, the Boundary launcher, and everything runs through this sales app. The client is not interested in gameplay experiences at this point. They just want a more guided experience. They know their target audience. They know also that real-time controls and navigations can be a bit confusing. So what you saw before in the video was very guided. It's more like a hierarchical navigation system. The client is really keen on presenting the design as intended with full visual realism. And ultimately, at the end of it, we needed to create 100 marketing-grade renders from the model. So the kind of renders that you would see on the left there. But truthfully, they know that this project will last for 2 years, 3 years, 4 years. So the point was to create a complete digital assets for them up front so that we can, once this project is done, move on to building more outputs out of it. Films, I guess television commercials, and experiences, and all of this. Now, our goal at the Boundary, our ethos, I guess, we want to create beautiful content everywhere, whether it's film or images or interactive. It just has to look beautiful. This is really what makes everybody passionate about at the company. This island needs to look beautiful from the sky, beautiful from the ground, and all need to be film quality, even though all of these are game assets, I guess. But lighting needs to be full quality, shadows needs to be full quality. The challenges that we have, well, we have a budget, right? We have a limited amount of time to create bespoke models or remodel. So most of the time, what happens is we receive models from engineers and architects and landscape architects, and we just have to use this. And we don't have infinite amount of time to reprocess this and make it look perfect for Unreal. And what Unreal is expecting out of a model for it to render correctly. So this is a challenge for us. Not everyone working on these projects have studied games. I'm sure like anybody who works in architectural visualization industry understands this, that we use Unreal and we use gaming tech, but really our people haven't been trained for it. So it's my job to create a pipeline that translates well from their knowledge of the architectural visualization industry. And that is definitely a challenge. The other challenge is scale. When you create anything in Unreal, I mean, you can really output any kind of project you want out of Unreal, but as soon as you add scale as a factor, everything becomes more complicated. Technologies start to break apart. You end up with a lot of crashes. There's a lot of unexpected things. Constantly, troubleshooting every day. That's my job. Cool, so how do we do it? Well, first, let's start with World Partition. It's a distance-based level streaming system, as you all know. And this is how we structure our worlds, I guess. And this talk is not really about how we process the data that we've been sent, and this is going to be the extent of me explaining it, so this graph there. So we receive a lot of different data, GIS, architecture, landscaping, furniture, and we process everything in diverse DCC software. So it could be 3ds Max, could be Houdini, could be Navisworks. There could be Datasmith, maybe not. Most of the time we don't use Datasmith. We tend to just go with a standard FBX pipeline because it gives us a chance to clean everything, I guess. And GIS is an important one. All of our projects are geolocated or accurately geolocated, and that's going to be useful in the future if we wanted to turn this project into a digital twin, I guess, so that we can easily get some APIs, just plug in some live data, and make this whole thing a little bit more interactive, I guess. So all of these are plugged into 3 places, I guess. Either straight up into the World Partition map, and usually that's the context, anything that's shared between all the other assets, so like the landscaping. Then everything else is put into either a level instance or packed level actor. Usually level instance will have the big buildings, the architecture, the villas, the amenities, the districts. And the packed level actors would be used to create furniture sets. As you can see, I'm not going too much into detail as to what are the difference between the both. I think this is going to be just the general theme with my talk is I'm not reintroducing you to what Nanite is and Lumen is. I'll just tell you how we use it, I guess, and what we've learned out of it. So yeah, if you wanted to learn a little bit more about level instance and packed level actor, definitely check out people like Chris Murphy and Matt Ostele. They're amazing tutors. Cool. So yeah, this is, a lot of it is kind of a piece of a puzzle that we have to ultimately put together. So all of these, they're being streamed at runtime using a runtime grid. And all the actors in the world need explicit streaming rules. Either they need a streaming grid, they need to be always loaded, or you need to load them through data layers. So what you can see on the right there is how we structure our world. We have 3 ways of importing assets. We have first the things that are always loaded in the world. So these are the critical actors. You get the context, you get the water, you get the palm trees, stuff that we can't really make disappear, or else we're just going to break immersion, really. Next level, we have the architectural assets, the thing that the client is selling, super high priority. It can never look bad. So these ones, they're put into a runtime grid, a base grid, which loads from quite far away, but also we build HLOS for these assets. So it always feels like the buildings are there. And yeah, they always look good. And then finally, we have a more or a closer grid, a near grid, that more aggressively calls, I guess, the geometry that's in it. And this is where we put all the dense detail for mid and ground views. This image shouldn't have gone away. And finally, you will also need to set up World Partition string volume for additional controls. And it'll make sense in a second. Cool, so what it looks like is what you see there on screen. So this is an editor, and this is the preview of the different grids. So in orange, you get that base grid, which has the architecture. And in blue, you've got the near grid, which has all the dense geometry. And then at play, using the runtime hash 2D grid, you can see that on the left, we get the near grid. On the right, we get the base grid. And you'll notice that there's a big blue circle surrounding like the entire island. This is us preloading everything that's inside the project using a streaming volume. So we've preloaded everything, and what we're doing with the streaming source that's attached to the player is basically toggling on visibility. So yeah, this is definitely something that we've noticed. World Partition is good, but not good enough for us to load dynamically hundreds of thousands of objects, every second. So we kind of have to do a little bit of the work for it and preload everything into memory because we have spare RAM. And then we purely just need to just show this. And then, so finally, at the ground level, you got all our level instances. So level instances, they're great for splitting and organizing the work. So we've got, say, 40 hero assets, 30 villas, 10 amenities, and all of these need to be worked on by artists. And this is just a great way for them to work through it. So our artists don't work in the main world. They usually work inside the level instance like this. It just makes it a little bit less confusing. And when you do this, the issue is that because these are level instance, you cannot have sub-levels, obviously. So if you wanted to bring on your own light and your own floor and your own pre-made lighting system, what you can do is toggle on is made world only on all the assets that you don't want to go into the World Partition level and you want to stay in the persistent level. So most of our level instances are set up like this. They have this space lighting. Do nest level instances together to create districts or regions. And again, that's just going to enable artists or groups of artists to work on a particular part of the project and just focus on that. So they still have the ability to go back to the World Partition level if they wanted to see how everything fits together. But most of the time, this is what they'll see, really. They'll see their own assets. We use 5.3, by the way. I should have said this at the beginning. And so there's a lot of ways we're approaching everything because we're in 5.3, and a lot of problems have been solved by Epic. So you might probably be thinking, yeah, I don't have this problem, but hopefully maybe you can also come talk to me later and tell me the solution to a problem that I'm going to be showing here. Yes, so in 5.3, you cannot access the runtime value that's on each actor from the main world, I guess, like anything that's stored within the level instance. So if you have a couch in a level instance and you wanted to load it in a near grid, you cannot do this, I guess. So what you're going to have to do is somehow bring everything that's supposed to be in the near grid together and everything that's supposed to be in the base grid together, and then in the main world, give them that runtime tag. It's very tedious. We've been using filtering to do this, or level instance filters, but yeah, as soon as we move to 5.4, I think this will be resolved. Okay, so we use a virtual render pipeline, and you all probably know what it is. We get Nanite, we get virtual shadow maps, we get Lumen, and we get streaming virtual textures. So these are high-end features made for high-end hardware. All these technologies heavily lean into the concept that we are loading exactly the data that we need at the given moment, regardless of the size of the overall object they represent. And the thing with the system is, in my view, if you're going to use any part of this system, you need to lean into it completely. There's no half and half. You can definitely just use Lumen, and you can definitely just use Nanite, but there's efficiencies built in all these systems, amazing efficiencies, that I'll be pointing out later. And so, yeah, this is kind of a whole package, really, that. So first, Nanites. Yeah, higher triangle and object counts, scales incredibly well. I mean, we've been abusing it, really, over the last 2 years, with giant landscape tiles with tens of millions of polygon. And it allows for film quality assets with minimal optimization. Still requires optimization, but minimal. And it obviously automatic LODs. And you can see that we use it across all our projects, like everywhere. So I hope this view from where you see it is not making you dizzy or anything like this. But yeah, we're not forgetting any assets. And yeah, what Nanite gives us is massive draw call reduction. I mean, I've started doing all of this in 4.19, so my way of working was quite different. The thing I was worrying about were completely different than the things I'm worrying about now. Now I don't have to worry too much about draw calls. This is amazing. So what we've learned with Nanite is, well, you can't have everything Nanite because Nanite doesn't support everything. So anything that's, say, translucent, just use the other opacity mask to replace non-essential translucent material there. So that's mainly for assets that have a lot of different materials. So a boat with 20 different materials, you're going to need the boat to be in Nanite, but yeah, you're going to want the translucent material to not be translucent and instead be an opacity mask. If you're working with all the elements separated because you work in architecture, that means you can just have your glass and turn Nanite off, I guess. But in the case of assets like that, you're just going to need to use the other opacity mask. Yeah, ray tracing, Lumen, collisions, and more only traces against the fallback mesh of Nanite. That creates huge problems a lot of the time. So in this case, in the example there, you can see that this buffer is telling me that my ground is under the planting, but in reality, what ray tracing and Lumen sees is that these plants are under it, and this is why they're black, and this is why it's all noisy and all messed up. So you're going to need to fix this, and you fix this by setting a lower fallback target relative error per mesh. So in this case, it's set to 0.025. You can also set a fallback percentage. Two different ways of doing the same thing, really. Now, you don't need to do this on everything. This is really important for mostly like terrain tiles and things like this. Nanite does not write to runtime virtual texture. If you like runtime virtual texture, it can be a bit annoying. What we've ended up doing for our terrain tiles is making a duplicate of it, like another component on the actor itself, as you can see that Nanite RVT proxy mesh. And then this particular mesh, we disallow Nanite, we make it invisible, we don't affect distance sliding, and this is the mesh that's going to write to RVT. Cool, virtual shadow map. Yeah, it delivers high resolution shadows across the scene. So yeah, again, I used to love and hate cascade shadows and distance field shadows and far shadows and all this kind of stuff. I don't really have to worry too much about this. The way it works is it caches the information into pages, and these pages are basically, I guess, conserved between frames. And what you saw before was a mix of green pages and blue pages. Green means it's validated, it's all good. Blue means it's been invalidated, meaning it needs to be recalculated. So the goal really is keeping shadow cache from invalidating. That's the main priority. That's what I try to get as much green as possible. And yeah, VSM is amazing because it's got huge efficiencies with Nanite. The way Nanite work, by the time VSM traces shadows, Nanite triangles are batched into one big single mesh. So if your mesh are not Nanite and you want to use virtual shadow map, you're sort of going to pay a cost per asset, I guess. Well, with Nanite, it's all sort of one giant process. So with virtual shadow map, yeah, you need to aggressively go after invalidated shadow. you're going to need to make a decision on a per asset basis, if this asset should be allowed to invalidate the shadows, meaning should it update the shadows. Say if this asset has WPO on it, and there's wind animation, by default what's going to happen, and this is going to ask VSM to recalculate all the shadows, so it's going to create a lot of issues like this. So on a per asset basis, you're really going to need to, ask yourself what you need. Do you need moving shadows or do you need performance? I want moving shadows because it looks amazing, and I'm paying the cost for it, but it's okay. I can deal with it. I can gain more performance somewhere else. But what you can see there is you can kind of mix and match where the plants in the foregrounds, they don't really invalidate shadows, so like the shadows are not moving, but who cares? I mean, I wouldn't be able to say it. The tree, though, they are invalidating the shadows. So yeah, on a per project basis, per asset basis, you kind of need to decide what you want. Some optimization comments there. We got the virtual clip map first level limits. It limits the max 10 textile density of shadows up close. It just makes the shadow a bit less expensive when you're really close from assets. And then we get Nanite LED bias. So that produces shadows from worst version of the Nanite mesh. So you can basically produce shadows from a different LED of Nanite instead of calculating the higher density version of it. Cool. Next we got Lumen. We use hardware ray tracing, not surprising. We're in the architectural industry. We need the best looking GI and the best looking reflection, everything, everywhere. What you're seeing there is the indirect illumination view of the scene. So Lumen is great, handles imperfect scenes surprisingly well. This scene cannot be remodeled, like I mentioned before, and yet you can see that we're getting some light leaks, but it's doing the job really. It's providing this amazing GI for a cost. And yeah, it's totally worth it. So Lumen, a big limitation. So obviously you all know cannot render perfect mirrors. This is a deal breaker for high-end interior architectural visualization, and this is why our interior pipeline has been sort of forced to consider backlighting or stay with backlighting. Most of our clients would not be interested at all in what you're seeing on the left there. So until it becomes what's on the right, we're basically stuck with backlighting for interiors, which is a shame because it makes it hard to consolidate our pipelines together. We don't care that much with the exterior because most of the time you don't get to see mirrors like this outside. So I'm perfectly happy with the left view. And if the left view appeared dirty to you, it's again because, the reflection uses the Lumen scene and we cannot clean the model and remodel the model. So this Lumen scene is not the greatest really. If you use hardware ray tracing, which we do, you can turn off affect distance field lighting on your actors actually. So if you don't use distance field features, like if you don't use distance field feature in material or anywhere else, and you use hardware ray tracing, do turn off distance field lighting because they do cost a lot to calculate, and they do cost a lot, especially when you're having hundreds of thousands of actors, millions of actors, like I said, that are constantly streaming in and out. Every actor will have to stream its mesh distance field. So we tend to just disable it for most actors in the scene, affect distance field lighting. But if you really think you're never going to need this, you can also go to the config and just go with R distance field 0, and then you don't need it. The reason I don't do this is because I still want the distance field to be built up on the actor so that if I need to deploy this on lower hardware or if I need to do something else, say virtual production or whatever, I just want to be able to turn on software ray tracing. So yeah. That's something I've been doing that tech hearts in my team are not super fan of, but I'm changing the Lumen settings with the player's location. In this case, it's a really lazy way of doing it because it's a flat island. So what I have is a post-process volume that's just taking into account the first 5 meters of elevation. And when you're at 5 meters and below, we're increasing the final gather quality of the scene. And anything above this, we're reverting it back to 1, I think. That has a huge impact from these kinds of level there. But at the ground level, because you're really calling a lot of what you're seeing and you're only seeing a particular amount of things, then increasing that value is totally okay. all of this was for the Lumen, the GI, I guess, but in terms of reflection, you can lower your reflection budget with minimal visual impact. So I don't know why, but Lumen hides a lot of its feature through command. You can do what you probably used to be doing with screen space and ray tracing reflection. You can tell it to call off after a certain roughness amount. So by default, it's at 0.4. You can probably lower this to 0.3, 0.2 without really seeing anything. So in this case, this sphere is at 0.02. So you can see that when I'm putting this value at 0.01, we're not calculating reflections for it, and it's reverting back to, well, a final gather. Virtual textures. The entire project and asset library is set up for it. We didn't start like this. We sort of went half and half at the beginning. Kind of regretted that decision and made our material really messy. I'm totally in love with it. I think it's amazing. And yeah, I recommend people who work with projects this scale to use virtual texture. And by virtual texture, I mean streaming virtual texture and not, runtime virtual texture, which are different things. What you can do with it, well, you can load UDMs, so you can load hundreds of thousands of pixel textures. A lot of these worlds usually require us to be able to load like a large context around it. Yeah, so from it we load aerial renders, we have these splat maps there, we get like some flow maps and all of this, and we're not really paying that much of a cost for it. With virtual texture, you should configure the memory pool size per texture format group in the base engine ini. We mostly use DXT1, BC5, DXT5, and BC7, so we decrease the other pools, and we've increased these pools a little bit more. What this view enable you to see is, this is the residency view. It enables you to see how much of your pool you're using at any given time. So if the red line reached the top, it's usually by new, so you want to try to keep the yellow line low also. And then you've got this command VT dump pool usage. It helps you to identify virtual textures that are currently referenced. It's good for working out why certain virtual texture pools are blowing up. So yeah, I mean, virtual texture is pretty easy to use. It's easier in 5.4 from what I've heard. Apparently you can grow these pools on demand. We can't do this, so we're just setting these settings. Cool, so that was for the virtual pipeline. Now, it's not enough. You're gonna need to build another pipeline to meet the highest visual standards our clients and ourselves have. So I'm gonna walk you through some of it, how we deal with architecture, how you would deal with architecture if, say, you were starting and you wanted to start doing these kinds of projects. You're gonna need to start building yourself a versatile base material and have all the features that are expected out of any DC package, I guess. Cell bombing, triplanar, macro texturing, per element variation, displacement. Like we built a tile system, as you can see on screen there. So all of this needs to be available for your artists to feel like Unreal is a great software. Because if you just give them a PBR material, they're going to be a little bit frustrated. We use vertex color data a lot. I just mentioned before, per element variation. Unreal does not know what elements are, when you give it like a bunch of polygons, I don't think it knows what polygroups are or anything like this. And yet we use this a lot in architecture to be able to identify, what is an element to another and being able to put, hue variation and value variation. So what we do is in our DCC, which is 3ds Max, we just assign a different vertex color per element. And then we use this to do a bunch of stuff to it. But that's not the only thing we do with vertex color. We can do edge wear, we can do weathering. You can also store different effects per RGB channel. So you can have your variation per element in red, and you can have your weathering in green, and I don't know, something in blue. I can only think of two. If you work with architecture, you're gonna need parallax mapping. I don't know exactly what the right name is for it. Everybody calls it differently. But fake interiors that were made famous by the Spider-Man game. We don't usually get closer than this, so this is enough for us. If we do end up getting closer, usually we tend to turn it off. But most of the time we're not paying to model the interiors, so that's perfect for us. So Nanite has some limitation, as you know. I mean, it makes its own LOD. You can't really control what it's doing. And with architecture, you have a lot of thin geometry, so you're going to end up a lot of the time with aliasing problem or moire problem. How we solve this is we create custom mesh that we put on top of these objects, and then we give them, in this case, a tethered material that disappear over distance. So these kinds of thin geometry, they just don't appear over a distance because we're hiding them. So this is the kind of stuff you'll have to do in Unreal. Cool. Next, world position offset. This is how we add life to our world. We use it for trees, we use it for horses, people, dogs, golf, curtains, all this kind of stuff. We're using for water, it's doing our displacement on our water, and we're using it on our world as well, so to pretend that the Earth has a curvature. We're doing all of this with WP offset. And because WPO is expensive, you're going to have to be really careful about the distance that you attribute to each mesh. So in this case, as you can see, we're being pretty aggressive about what we're allowing to be moving, I guess. Ooh, I should have clicked. Foliage, we call it softscape. Our clients call it softscape. World Partition struggles most with large number of instances. So what we tend to do is per cell or per runtime grid cell, we really have like a number that we're trying to get to. Ideally, it's like 10,000 instances of anything. I mean, it kind of doesn't matter if you're spawning 10,000 cube or 10,000 trees. I mean, a little bit it matters, but it's just loading 10,000 objects in and out of memory or something. I guess it just start clogging up everything. So you really want to stay under this number as much as possible. And then, I mean, you're the one determining what your cell size is, obviously. Then Nanite struggles most with large numbers of unique static mesh. So if you work in Max with Vera and Corona, you're going to be putting 20 versions of that coconut tree there. And it's not something we can do. Ideally, we use one instance of one particular asset because it's way more efficient to just reuse the same polygons over and over again, I guess. Foliage tools in Unreal, they're really not suited for what we do. As an ArcViz studio, we work a lot with design data that has been provided to us by architects, landscape architects, and engineers, and our job is to represent this data as accurately as possible. And so we need to be able to plan things deterministically. We cannot just be planting things artistically, I guess. So you're going to need to get yourself a decent tool or build yourself a tool, either with PCG, make your own scattering system. You can find something on the marketplace that's going to enable you to plan things by the number, or you're going to need to build a custom tool, which is what we've done. We've built a tool that enables us to export data from a lot of different sources, either from point data, so from GIS data, from 3ds Max with Forestback, from Houdini if we wanted to, from Naviswork, and then we use this data and we create rules for it, and then these rules are used to spawn everything and optimize everything. So in this particular case there, as you can see, most of what you can see on screen is spawned within that tool, I guess. And so you're going to need to find a way to display something when you unload your foliage, especially if you're working with a sandy island like this. I mean, it can't look sandy. So you can see that if I turn off the tricks that I just showed you before, like it just looks quite sandy. So what we ended up doing in our case is we made a duplicate of the world, like we made a different world partition with just the plants, and we're using the minimap, literally the texture from the minimap, and we're using it on the material that we're using on the terrain. So, and over distance, it just shows up. And it happens sort of at the same distance as the plant disappear. So it never really feels like there's no plants, even though most of the time there's no plant. So you'll have to find your own way of doing this. But the minimap is actually quite a nice one. We're doing some cool stuff with post-process material. So on top of everything at the end, we have a post-process that enables us to do some saturation, some brightness, some hue. But we don't use it like this because that's just simple color grading. What we do is we mask it behind a shader model. And most of the time we tend to pick shader model 6, which is two-sided foliage. And then it enables us to, in post like that, just tweak all the foliage on the island. Not only this, but we have other types of mask. We have like a distance mask that we use, which means that we can now start tweaking our vegetation as we go further away from it. And this is really important because, Unreal looks quite realistic, especially in UE5. But realism is boring, I guess. We need to sell a dream. We need to make it dreamy. We need to make it better than real. So in this case, what we tend to do is just pump up all the vegetation when we get far away from it. So it stays vibrant, it stays magical. And yeah, you can do this with shader model. It's quite amazing. Cool. So we've built ourselves a sandbox, and we can do a bunch of stuff with it. In our case, we've created an interactive sales app. Oh, sorry, we have an interactive sales app. We've plugged it into it. We can start doing marketing, pre-rendered content. We can start doing virtual production. We can build experiences around it. This is wrong, this text, I'm sorry. And we can, build digital twins. So all of these will require a certain amount of effort, and usually you need to make that effort as you're building your pipeline, I guess. As you're creating your world, you need to make decisions so that when you end up at this point, it's going to be easy to take any of these paths. So digital twin, like I mentioned, because we're building it with geolocated data, we're sort of ready. We just need to wait for the data from the client and then become something a little bit more interactive. Experiences, we're using the best technology out there, that virtual pipeline. So we're getting film quality, everything everywhere. So to build experiences, that's going to be awesome. Virtual production, yes. So because we've been so tidy and we structured the world so well, we can just take a chunk of it, getting it out of the World Partition system, and just make like a particular level just for virtual production. And we've done it in the past, use Nanite and Lumen in the studio, and it works fine. All of this really depends on the studio that you use to actually do virtual production. Some of them are a bit more ready than others. But marketing pre-rendered content though, this one, out of the gate, it's not going to be that easy to just suddenly making renders that look as good as what the Boundary has been doing for 10 years. So there's a lot that we're going to need to do to get our world ready for us to do that. So this is what I want to focus on. So for this project, sorry if it's too bright, we had to create 100 images, marketing images from all over the place, daytime, nighttime, and they all need to look amazing. So really what this is a guide to path tracing, or at least a little introduction, and talking to you about the biggest problem we've had with it over the last 2 years and the recent solve that we found with it. And how to build a world that is ready to toggle on this path tracing switch and it to look amazing. So consideration, want to be able to create incredible looking content with minimal rework or model changes when we do path tracing renders. We're going to need to avoid the features that are incompatible with Path Tracer. So as much as I would want Nanite tessellation everywhere, and I'm very sad that I can't use it, I cannot have all my materials using Nanite tessellation as the base of making it look what it looks if when I turn on path tracing, it looks completely different. So it's the kind of the sacrifice that we're making there, and there's other features like this. But so until Nanite tessellation is, maybe it is, tell me after, maybe whoever is using 5.6. Until Nanite tessellation is compatible with it, we just can't use it. This is a no-no. Every image will need relighting. We don't intend to preserve lighting, when we change format. All of the outputs that I've mentioned before will require relighting. This is hopefully a given for anybody. Challenges, Path Tracer in 5.3 is still experimental. It's kind of a minefield. The challenge that we have is we're working with a live project. This project has a long lifespan. Any large project will have a long lifespan. This is going to be iterated on. Clients will change the design again and again and again over the next 2, 3, 4 years. And yet we have to start creating path trace render and marketing render, I love it, without making a mess. and anybody who's doing images and film knows how fast we have to work to get this possible and how messy these things can get. So this is definitely a challenge. And yeah, working with a large project with path tracing is really hard. So basics, I hope I don't need to teach you this, but you've got a level, turn on path tracing, boom, it looks good. Not exactly, actually. You need to change the Nanite ray tracing mode, because by default, ray tracing does not see, I guess, the full quality mesh from Nanite. And then after this, you're going to need to use your camera, ideally. I prefer this than the post-process to just tweak some settings. The settings are really easy to understand. You get samples per pixel, which defines how long it's going to be accumulated for. You get some bounces. We do a lot of exterior render, so we don't need that many bounces. Max path exposure. Usually, this is something you want to set a few tick above your exposure. You can check what your exposure is using the HDRI eye adaptation mode. In our case, we're about like 0 or 1. We don't use physical values. So that means that you need to set your max path exposure just above this. And this is going to stop the accumulation. A few exposure tick above your current exposure, if I understand, is going to stop fireflies and things like this. But that's effectively it. Then you need to consider if you want to calculate the depth of field, if you want to use the atmosphere or the skylight for your GI. And then you need to do, obviously, a little bit of post-production. And then it looks good. So there's a bit of setup that we need to do before that. Yeah, you need dedicated path tracer settings in most of your master material. And you're going to need to use the path tracing quality switch node. In translucent material, as you can see there, I've got a path tracing section and a Lumen section, and all those settings are quite different. That's just what it is, really. I mean, the biggest one is going to be probably index of refraction. It's accurate for path tracing, and for Lumen, it's whatever to make it look good, I guess. Same goes with well, it's not translucent. For two-sided foliage, the subsurface value, you're going to need to pump that up quite a lot in path tracing, so we have like a booster just for that feature. You're going to need to be careful when you build your world if you want to do path tracing stuff. Nanite dynamically instance actors, it's amazing. But when you turn on path tracer, you end up back in the old ways of working, I guess. So if you haven't structured your world with instance static mesh components, you're going to crash. You need to instance things the old way with path tracer. So even though Nanite is amazing and automatically instance everything, we're still using ISM throughout the project. You need to build yourself a custom camera with tilt correction. This is just a requirement for the ArcViz industry, really. Either using a plugin from the marketplace or build your own. Okay, so now we got 100 shots to do. Something I haven't shown in this slide here, but one thing that I tend to recommend is to make a duplicate of the World Partition level and basically make a marketing version out of it. And if everything inside your World Partition level is level instance, then you can reuse these same level instance. But then the world itself is just a different one than the runtime one that you're using to package. It's definitely a good thing to do because artists would screw your setup, I guess, because they have to work fast. So yeah, first you make a duplicate of that World Partition, keep all the assets inside the same, and then you're going to need to create, one shot, one sequence, and everything is allowed within the confine of the shot. You can replace the lighting, replace the post-process, hide actors, add actors, replace foliage with Alembic for animation, for example. Why not? In 5.3, this big limitation, you cannot access the actors within the level instance. So if you're trying to hide the parallax mapping, for example, because you want to see the interior, unfortunately, you're going to have to break that level instance. And usually what we tend to do is make a duplicate of it, hide the original one, break the new one, add everything into the sequence. It's crazy. I don't like that. Rendering. So how do we consistently generate clean and sharp high-resolution render without crashing? With less crashing. It's going to happen. You can either use the high-res screenshot within the editor for still imagery, or you can use the movie render queue for animation, or if you want to batch process a lot of still, I guess. I'm mostly going to focus on the high-res screenshot because the movie render queue is quite a long topic. Yeah, so it's pretty simple to use. You use the high-res shot command and input your desired resolution, as you can see at the top. So you want a 5K render, high-res shot, resolution 5K. You're going to need to set up your high-res screenshot delay in accordance with samples per pixel setting on your camera. So if you have 375 on your camera, just put something like 400. The delay equals to frames equals accumulation. So effectively, these numbers are the same, I guess. And it's as simple as this. What I tend to do, though, I tend to always test one sample before committing to a greater number, because these can take quite a while. By quite a while, I mean, between 20 seconds to 2 minutes. It is still amazing. But you will still end up with a lot of troubleshooting. It's not that straightforward, unfortunately. You're going to end up with a lot of crash, a lot of freeze, especially when you render at high resolution. And there's a couple of things that I wanted to talk about. Blurriness issues that we've had over the past 2 years, whether in movie render queue or with the high-res shot command. In movie render queue, it's mostly because we're trying to use a mix of spatial samples and temporal sample, and you shouldn't do this. You should just use spatial. But in high-res shot, it's all spatial, so there's no reason why we would have blurriness. So here on the right, I get 3 examples where I did some render at 1080p, 4K, and then 7K. And when I zoom onto these samples, you can see that they're very sharp on the first 2, and they're blurry on the last one, the 7K render. As if it rendered it in 4K and then upscaled everything after the fact. Why would it do this is because you need to increase the viewport max rendering resolution and force it to be the highest resolution that you need to render that shot for. And then you're going to get clean samples for that particular resolution. And then you're going to start crashing because you're going to run out of VRAM. And that's one thing that stumped me until recently. So resolution-based crash. I realized after hiding everything and just turning on things one by one that convolution bloom for us, at least at the boundary, was the thing that consistently crashed everything. And turning it off was a guarantee to be able to render, 7K shot, 14K shot even, if we wanted to. The reason why, I'm not too sure, but here on the right, I've got a few examples where rendering a 7K render with a delay of 3. Convolution bloom, the render takes 3 seconds, the VRAM has no impact. With convolution bloom on, the render takes 30 seconds, and I've bottlenecked my VRAM. And this will keep on happening again and again. So what we've been doing recently is either turning off convolution bloom or reducing the bloom screen percentage. You can do that. So what you can do is build yourself a tool that's going to do all of this automatically. Put a resolution, it's going to automatically downgrade this bloom screen percentage. And then from this tool, you can also set your path tracing samples per pixel, your delay, your Nanite mode 1, your viewport max rendering resolution. And so far, it's been very good for us. I only have a minute left. Animation, I'm going to go really quick. So these are our settings, but really the thing I wanted to talk about, if you're rendering from a World Partition map, which has 8 shots, you're going to need to do some start console command and end console command to disable and re-enable these 8 shots, or else you'll crash. They're at the bottom there, on the right. You're going to need to, if you want WPO, you're going to need to do 2 things. Turn on WPO ray tracing on static mesh, and make a non-Nanite mesh version of that asset, or else it won't render WPO. So if you want a tree and you want the wind out of it, make a non-Nanite one, replace it in the sequence, render it like this. And also, you're going to need to set up a streaming volume in the sequence that's only going to stream exactly what you want, or else you're not going to get the actors that you're expecting to when you press render with movie render queue. So, yeah, that was me. We talked about how we build the worlds, the world partition, the virtual rendering pipeline, some cool art pipeline. We've made a sandbox, and hopefully I taught you a few things about path tracing that you didn't know. Thank you.